Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one type of question cost more marks than almost any other on last year's GCSE Higher papers, and it's often not because the maths is hard, it's because students leave an answer as a decimal when the exam wanted an exact surd. Sound familiar?
Oh yes, I remember converting answers to 2.6 and losing a mark when the question said, give your answer exactly. Felt like a trap.
You're not alone. In plain language, an exact answer keeps square roots where they are, like 2 minus square root of 3, instead of writing 0.2679. In this episode, I'll show a short routine, recognise when exact is required, simplify surds by factorising, rationalise denominators when needed, and add a quick algebraic check you can do in under 20 seconds. Here's the roadmap. First, the concept and simple examples, then how examiners award marks, a 30-second rationalisation trick, a worked 4-mark question, and a one-line recap. Ready?
The concept. Step 1. Simplifying surds. Start by looking for square factors. Why? Because square factors come out of the square root as exact integers. For example, take square root of 50. We spot 25 as a square inside 50, so square root of 50 equals square root of 25 times 2 equals 5 root 2. That's not a trick, it's algebraic factoring. If you write square root of 50 as 7.07, you lose the exact form and the examiner sighs.
Worked example 1. Simplify root 50 plus root 8. Step 1. Factor inside each root. Root 50 equals 5 root 2, root 8 equals 2 root 2. Step 2. Collect like terms. Both are multiples of root 2, so 5 root 2 plus 2 root 2 equals 7 root 2. That final form is the simplest exact form. Write down the factoring step. Examiners want to see it. Write it down, don't just think it.
So the key is pull out the biggest square factor first, then combine like roots.
Exactly. Worked example 2. Simplify 2 root 12 minus 3 root 27. First factorise. Root 12 equals root 4 times 3 equals 2 root 3, and root 27 equals root 9 times 3 equals 3 root 3. Now substitute 2 times 2 root 3 minus 3 times 3 root 3 equals 4 root 3 minus 9 root 3 equals minus 5 root 3. Notice how factorising reveals the common root 3, so you can collect terms. Let that sink in.
The concept. Step 2. Recognise simplest exact form. For a single surd, use integer factorisation. For expressions, check whether surds are like terms. If a denominator contains a surd, and the question asks for an exact answer, we rationalise. That brings us neatly to rationalising denominators.
Exam technique. What the examiner wants. Let's take a typical 4-mark AQA-style question where exact form is required. Marks are usually split into method and accuracy. M1 for the correct algebraic step, M1 for the manipulation, M1 for simplifying intermediate surds, and A1 for the final exact answer. If you skip steps, you lose the method marks, even if your final number looks right.
So if I only write the final simplified surd without showing the factorising, could I lose marks?
Yes, especially on the higher paper. Examiners award method marks for clear algebra. For example, write root 50 equals 5 root 2, M1, root 8 equals 2 root 2, M1, combine to get 7 root 2, A1. That's writing the path to the answer. If you show the factorisation, you secure those method marks, even if a small arithmetic slip happens later.
Common examiner pitfalls: converting to decimals,
leaving denominators irrational when the question asks for exact, and cancelling incorrectly between unlike surds, like trying to cancel root 2 with root 3. Also, don't forget to simplify fully. 5 root 2 is simpler than root 50, so show that step. Quick win, the 30-second rationalisation trick. If you have a denominator like 2 plus root 3, multiply top and bottom by the conjugate, 2 minus root 3. That gives top multiplied by 2 minus root 3 over 2 squared minus root 3 squared, which is something over 1, because 4 minus 3 equals 1. So 1 over 2 plus root 3 equals 2 minus root 3. Quick algebraic check. Multiply your final result by the original denominator. You should get 1. Do that in 10 seconds and catch many errors. Exactly. That's your quick win. Keep that two-step routine. Multiply by the conjugate, then do the short multiplication check. If the denominator simplifies to an integer, divide and give the exact surd form. Worked example recap. A full 4-mark question, exam style. Question. Simplify 3 root 50 minus 2 root 8 over root 2, giving your answer exactly. Step 1. Write it down. Expand surds inside the numerator. Root 50 equals 5 root 2, root 8 equals 2 root 2. So numerator becomes 3 times 5 root 2 minus 2 times 2 root 2 equals 15 root 2 minus 4 root 2, M1. Step 2. Collect like terms. 15 root 2 minus 4 root 2 equals 11 root 2, M1. Step 3. Divide by root 2. 11 root 2 over root 2 equals 11. That's a correct simplification and the final exact answer, A1. Examiner commentary. You earn method marks by showing each algebraic step. Factorise, combine like terms, then cancel the common surd. Even if you made an arithmetic slip earlier, showing your method can salvage marks. Nail this and you're halfway there. That felt straightforward when you wrote each move down. Quick checklist to use under timed conditions. 1. Read exact in the question. Stop and note it. 2. Factor square factors from surds. 3. Collect like surds before cancelling. 4. Rationalise denominators using the conjugate if asked. 5. Do a 2-second check. Multiply back or square to confirm. Read the question twice, solve it once. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more work solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.